What is a software developer looking for when reading machine learning code? And is it different than for regular, non-machine learning code? Machine learning is becoming ever more ubiquitous, and ensuring that these systems work certainly is a good idea. And the developer seems to be a good starting point for quality control. Now, for general software development, there's plenty of prior work to figure out how developers work. For machine learning, not as much. Ideally, we could just transfer all the knowledge we already have to machine learning. But is that valid? Machine learning is a very different development paradigm. It is not algorithms that define the behavior, but data. So this is why we thought that the comparison of those two paradigms would be worthwhile. And we started for now with reading behavior. So, what did we do? We conducted an eye-tracking study where we had 6 developers sit down and read some code. Specifically, they read Python code, which was the obvious choice, since it's used a lot for machine learning, but also for other non-machine learning things. In total, each had 8 small pieces of code, 4 of which were just general Python examples, and 4 used actual machine learning, like the Iris or MNIST datasets. To make sure the code fit onto the screen, it was relatively short, so we stuck to examples you would find in a typical machine learning introduction. Now, after gathering some demographic info, every participant had to read each of these code snippets in a little UI, where we showed the code and then asked them to summarize what it does and whether they noticed anything. After the study runs, we first visualized the data in these heat maps, and as you can see, there are already some interesting patterns. If you look at the one on the left side, which is representative for the people who reported little machine learning expertise, we can recognize reading patterns which resemble Nielsen F patterns, where they start at the top left and then scan through the code mostly line by line. Compare that to those that claim to have some more expertise who really just skip most of the early parts, which usually is just a bunch of imports, and spend much more time in details, in this case some configuration patterns. Now, to be fair, with 3 more and 3 less experienced participants, it's hardly a pattern, but it certainly is worth further investigation. We then split the code into smaller parts to see what areas are especially interesting. So what we did is to basically label every area with what type of code it contains, for example literals, conditions, etc., and then check the dwell time for each area. And this now allows us fairly rigorously compare machine learning and non-machine learning code. This also highlights a considerable challenge. While we try to have our code examples relatively comparable in terms of length and complexity, not everything from the formal grammar is equally represented. Anyway, to at least account this, we normalized our dwell time based on how much space each code construct takes. So, in theory, if everything were equally interesting, it should be the same proportion. But, as you can see, this isn't really the case. There are some things that are disproportionately more interesting, for example loops, function calls, and some are much less interesting like imports. And this kind of applies to both types of code, but there are also some differences. For example, in traditional code, the control structures, loops, and conditions appear to be more important, while in machine learning, code imports are slightly more interesting, and especially index-based operations appear to be relevant. So, in summary, we think that it's important to investigate how developers interact with the systems they write for people, especially with machine learning. From what we can tell so far, there are some differences between machine learning and traditional code, regarding reading, but also just general structure. Of course, our results need to be expanded upon by checking on how much more experienced developers read code, whether the same applies for larger, more complex software, and so on. But also, this is only a first step, which ultimately should also lead to methods that help them write better software and better machine learning systems.